This is the next question. Two bodies are thrown at the same time in opposite direction with equal velocity v0 at angles alpha 1 and alpha 2 to the horizon. What is the velocity with which the body moves relative to each other? And second part is, what will be the distance between the bodies after time t? So in this case, it is given that the initial velocity is v0. We have two projection angles alpha 1 and alpha 2, and both are to the horizontal. So let us find out the horizontal and vertical component of both the bodies. So let us say for body A, we call this as VH horizontal component, that is V0 cos of alpha 1, and vertical component V1 small v V0 sine of alpha 1, and for the body B we find V2H, that will equal V0 cos of alpha 2, and V2V will be equal to V0 sine of alpha 2. So both the bodies are projected in the opposite direction. So one is going in this direction, let us suppose alpha 1, and another one is going in this direction, that is alpha 2. So we can say that the horizontal component will be in opposite direction. So we can say this is V1H and this is V2H. So it means the relative velocity with respect to each other can be given as V relative in the horizontal direction will be V1H minus V2H. This can be further written as, if you substitute their respective values, we get V0 cos of alpha 1 minus V0 cos of alpha 2. We can take V0 as a constant outside, sorry, it's a common, not a constant. So we get V alpha 1 and cos alpha 2. So this is V relative horizontal. Let this be equation number 1. Next, similarly, we find that V relative in vertical direction, we are going to get V0 sine alpha 1 minus sine alpha 2. Let this be equation number 2. So total velocity with which the bodies move relative to each other, we get V relative is equal to V relative in the horizontal direction square plus V relative in the vertical direction square and its square root. So this can be written as V0 cos alpha 1 minus cos alpha 2 square plus V0 sin alpha 1 minus sin alpha 2 square root, and this will be whole under the square root. So it means V relative can be further solved as V0 square cos alpha 1 minus cos alpha 2 square plus v naught square sine alpha 1 minus sine alpha 2 square and its square root. So we are going to take v naught as common outside the square root, and we are going to open the square. We get cos square alpha 1 plus cos square alpha 2 minus 2 cos alpha 1 cos alpha 2, this is the first part, plus sin square alpha 1 plus sin square alpha 2 minus 2 sin alpha 1 cos alpha 2, and this will be under the square root. So cos square alpha 1 plus sin square alpha 1, this will be coming as 2. Similarly this will be coming as 1 plus cos square alpha 2 plus sin square alpha 2 will be 1. Okay, and we will be left with minus 2 cos alpha 1 cos alpha 2 minus 2 sin alpha 1 sin alpha 2 whole under the square root. So we can write this as v naught. This will be 2, and if we take 2 common from the entire thing, we will be left with 1 minus cos alpha 1 cos alpha 2 minus sin alpha 1 sin alpha 2 square root. So this will be nothing but a 1 minus 2 cos alpha 1 minus alpha 2, simple trigonometric identity. This will be equal to v naught, so square root also. This will be v naught, and we are left with, if we further solve this, this will be giving us 2 sine alpha 1 minus alpha 2 divided by 2 square root 2 multiplied by 2 4. So we are taking this as common, 2 v naught square root of square. It will be coming as 2 v naught sine alpha 1 minus alpha 2 square divided by 2. This way v relative velocity. The second, we are going to find out the time period. So in order to find the distance between the two bodies of the time period, we are going to use both horizontal and vertical position as a function of time. So in the horizontal position we can write x1 is equal to v1h multiplied by t. Similarly for second we can write x2 is equal to v2h multiplied by t, and y1 will be equal to v1 t minus half gt square, and y2 is equal to v2v t minus half gt square. So distance between two bodies, simple distance formula we can use, which states that x1 minus x2 whole square plus y1 minus y2 whole square. Square root will be giving us a distance. If you substitute the values, we get v1 comma h multiplied by t. x2 is v2 h multiplied by t whole square plus y1 is v1 v t minus half gt square minus v2 v half gt square whole square and square root. Now we are going to put the values of the respective values. So we can write this as, okay, first of all let's solve it before putting values. v1 v2h square t square plus we get v1 v t minus half t square minus v2 v t plus half gt square. So this cancels out and whole square. Now we are going to put the respective values. So first value will be v0 cos of alpha 1 minus v0 cos of alpha 2, its square root t square plus we get v0 sine alpha 1 minus, and we left with v0 sine alpha 2 whole square t square. Now if you open this bracket, we can further solve it, and we are going to get this as v0 square 2 minus 2 cos of alpha 1 minus alpha 2 t square and square root. This will be equal to v0 2 minus 2 cos of alpha 1 minus alpha 2 square root multiplied by t. This can be written as twice v0 sine of alpha 1 minus alpha 2 divided by 2 to t, and this will be distance. So after time t, this is the distance which I found out as 2 v0 sine alpha minus alpha 2 divided by 2. Thank you.